Hello and welcome to this third of 4 videos on the data logging shield. So this is my microSD card, my real-time clock, so that I can save the data with a timestamp. And in this video, I'm going to use one of these, or actually going to use a couple of these. This is the nRF24L01. It's a radio frequency transceiver. You can see it has 2 rows of 4 pins. So in a previous Instructable, I made an adapter for it, so you can see, if you want to see that, there's a link in the description. But basically, the transceiver plugs in there. That plugs into these rows of pins here, and then I just plug in here. I'm going to plug into the 3.3 volts. Okay. And so because I'm using a transceiver, I need 2 of these. So let me just zoom out. Okay. So in this demo, I'm going to have, this is going to be my server. Okay, and so it has the data logger on it and the transceiver, so it's going to receive data, record the time it received it, and then save to the microSD card. Okay, and then I need another Arduino. So this one here has, this is actually the first shield I ever made, but it has the nRF24L01 already on it. And so this Arduino is going to be plugged in, and it's going to have similar to a previous demonstration. It's going to have this thermistor and then a 10 kilo ohm resistor. Okay, so the thermistor is going to be plugged into 5 volts. Okay, let's just do that. Then it's going to be connected to one pin of the resistor, and the other side of that resistor is going to be connected to ground. So the thermistor and the resistor make a voltage divider. And as you know, the thermistor will change voltage, change resistance with changing temperature, and thus change voltage. And that's going to be plugged into analog A0, so it can measure that voltage change. Okay, and so then this Arduino is going to be my client. Okay, so it measures temperature every 10 minutes, and then sends just that temperature data to the server. Okay. Okay, and so when this receives data from the client, it is going to, well, actually it's going to send an acknowledgement back, and then it's going to save with the time that it received the data. Okay, and so then this is my demo number 3. Okay, so let me show you some of the programming. So let's go to the computer. Okay, so here we are at the computer. You can download a copy of these 2 sketches from the Instructables. You'll notice some of this is similar to the previous demos, so I'll go through some of it very quickly, but the new part is from the Radiohead library, and there's a link to that in the Instructables. This has a number of examples. We're going to use the reliable datagram for the nRF24, and specifically we're talking about the server, right? The one that receives the data. So there is some setup and some libraries for this with the reliable datagram and the Radiohead library. So we're going to use the reliable datagram library and the Radiohead library for the nRF24, and that nRF24L01, it communicates through SPI. Now this reliable datagram actually sends and receives messages, data, to specific addresses. So each server and each client will need an address. So since this is my receiver, my server, it's going to have an address of 1, okay? And currently now the client, right, the one that's sending the thermistor data, is going to have an address of 2. Okay, and so we're going to set up the nRF24L01 where we declare an instance of the driver. We let it know what the address is of our server. Okay, the receiver. This is the receiver. When we send our acknowledgement message back to the client, it's going to just be this OK message. We need a buffer to receive data. Okay, so that's all the setup for the nRF24L01 using the reliable datagram example from the Radiohead library. Okay, and then we need to set up our microSD card reader. So we're going to use the SD library again. Again, it uses the SPI library, so we don't need to duplicate it. Our chip select pin is 9 as before. There's a lot of serial statements here, again, just to let me know where I am in the in this sketch. And so if something goes wrong, then that helps me troubleshoot. But once you have your project set up and it's not connected to a computer, then you can turn that off. Okay, you can erase all the serial begin statements. We're going to start up our real-time clock here. And then we're going to actually start up our nRF24L01. So if that doesn't work, we're going to send a message that the nRF24L01 failed. Okay. You'll notice this F macro. So when you create a serial print statement, it usually saves it into RAM, right? And there's only 2 kilobytes of RAM in the Arduino Uno. However, with this, you can save this message to the flash memory, right? And there's a lot more flash memory than RAM. So when you're creating a long program, and this is using, several libraries, the real-time clock, the SD card, right? The nRF24L01. So sometimes you start running out of space. So this is one way to kind of reallocate those messages to flash memory instead of RAM, okay? Obviously, if you make these shorter, that would help too. But anyways, if it failed, then it's just going to stop the program. Okay, but assuming that everything works, and it's going to skip down here, and it's going to initialize our micro SD card reader. Okay, so we start that up, same as before. Okay, begin the micro SD card. Again, all these messages are in flash. And then we're going to open our file. So this file we're going to call log3. Okay, so a third demo. We're going to set up the blank line and then the headers for each of those columns. Okay, so the month, the day, hour, minutes, and seconds when we receive the data, and then we're saving temperature data, so it's going to be Celsius. Okay, once we've printed to our SD card, then we're going to close it. Here we're just confirming by sending the same thing to the serial monitor. Okay, if this didn't work, okay, if it didn't open that file, then this wouldn't have worked, and then we would have skipped down here and then just let the user know that we couldn't open the file. Okay, and then end the program. Okay, so assuming everything is now finished and set up, then we go to the loop. And basically this is just an if statement. Okay, and then if there is data received in the nRF24L01, then we're going to run this code, okay, all of this code. Okay, otherwise, it just goes through the loop over and over again, just waiting to receive messages. Okay, so we set up some integers, unsigned integers of 8 bits here. So one for the size, one for the address of where we received the message. Okay, so because we received a message, then down here we're going to update our clock data. So we access the real-time clock, get the date and time, save that into the Arduino. And then here we're going to send our request, our acknowledgement back to the address that we received the message from. Okay, and so this is from the reliable datagram example, basically just printing out with that we got a request from 0x, and then you print the address. Okay, so it's going to be address number 2 because that's what we have for our client. And then the actual message, it prints it out. Okay. So this is just to send to the serial monitor that our acknowledgement was sent, what message we got. But again, once you get your project set up, you can remove these lines. Now this part here, we're going to get our data, and we are going to save it to a string, okay? And that's the string that we're going to save into our microSD card. So a lot of this section of code actually comes from a tutorial from Kevin Dura called Strings. So it's very useful, actually, very good tutorial. Here's a link for it, and specifically lesson 7 of that tutorial. So in that, he kind of shows how to convert, different integers into strings, how to parse the data and pull certain things from a string of data. So a very useful tutorial. In any case, we're going to create a character array called data log. So this is what we're going to put all of our information into so that we can save it to the microSD card. Okay, so it's going to be in the right format so we can save it. And to do that, we're going to use this sprintf function. So it's an Arduino function. And we're going to tell it we're going to print to our character array. And then these are the different values that we're going to insert. An integer, an integer, an integer, an integer, an integer, and then a string. Okay? And this string is the data that we received from our nRF24L01. Okay? And so we've told the Arduino now what kind of variables we are saving to our data log, and then we tell it what those actual integers are. So it's going to be the month from the RTC, the day, the hour, the minute, the seconds, and then again here again, this is the data that we received wirelessly from our client. Okay, and so all of this is going to be saved with commas into our data log. Okay, so this needs to be big enough to take all of that data. One thing I'll point out is these are supposed to be bytes, not integers, but when I try to do %sign and B to tell it it's a byte, each one of these, for some reason it didn't work. I'm not sure why. So right now, each of these, I've told it it's an integer, but I'm pretty sure these are actually all bytes. Okay, I'm not sure why that didn't work. But anyways, doing it this way, it does save all that information to data log. And then here, just to confirm, we write out what our data log is. So you'll be able to see on the serial monitor what should be saved to the microSD card. And then down here again, same as before, when we put in the headers, we're going to open the file, log3, comma separated value file. If that worked, then we're just going to print to the log file our character array, okay, our data. So all the date, the time, and our temperature. Once we've finished writing, then we'll close. Here we're just going to flush flush our buffer. Okay. If for some reason we couldn't open the file, then we write that message here. And then we send our reply back. Okay. We send back our OK message. This just tells it the size of it. Okay. But of course it can figure out from our it can figure out from our message what the size of it is, and then again, this is the same address that we received from. Okay, if it didn't work, then we're just going to write send to wait failed. Okay, and that's it. Once it's done, then again, it goes back waiting to see if it receives any more data on the buffer for the nRF24L01. Okay, so that's our receiver that our client, this is the one sending the data. So here in this sketch, this is what's uploaded to the client. Okay, this is the one with the thermistor that's actually sending the data. So we're going to measure the data on analog pin 0. So we just declare that temperature pin here. And then because we're only going to send every 10 minutes, we're going to use the millis function. So we need a couple of variables to help use that to compare to millis, so we know when it's time to measure temperature and when it's time to send data. So we're going to use previous millis, so that the previous time we sent, and I use this high, usually I start at 0, but using this high value here, and I can show you below, but just because I want to send the data the first time we start up the program, not waiting 10 minutes before we first send. But I'll show you that below. Our interval here is going to be 600,000 milliseconds, and that's because we want to wait every 10 minutes before we send new data. Okay, so that's what our interval is. And then similar to the server, we're using the Radiohead library. We're using the reliable datagram example, but specifically for the client. Okay, because this is our client Arduino. So a lot of it's the same, using the reliable datagram and nRF24 library. I forgot that the SPI is actually included as part of the nRF24L01, so you don't actually specifically had to call it, even though I did in the server sketch. But if you don't have it, it should still work. Again, our addresses. So this Arduino is the client, so it's going to have an address of 2, and we need to know who we're sending to. Okay, so we're sending it to address 1. That's going to be our server. Okay, the one with the data logger. So this is the same as before. Here, again, we're telling the Arduino which one we are. Okay, we are the client in this case. And then we set up our buffer. Again, we're using the serial statements for troubleshooting, but you can delete these once you get things going. Here is, again, same as before, saving this to the flash. That's what this macro is. Okay, so we're initializing it. If it doesn't initialize properly, then we're going to say that it failed. So here we are in the loop, and we're only going to run this code if it's time. So here we have the millis, so the current number of milliseconds since we last started the Arduino, subtracting the previous millis. Okay, so the previous time that we sent. So remember when we started, it's 9,999. So these two are not going to be greater than the interval the first time we go through the loop. However, these two lines mean or, and then if the millis is less than the previous millis, which it's going to be because we set this at 9,999, so that then I just use that because I want to run through this the first time we start up the Arduino, and then after that, when we update the previous millis to the current time, then the next 10 minutes this will be true, and then we'll run through it again. Okay, so I hope that made sense. I just want to start the first time around, and then every 10 minutes after that. And as you remember from the previous sketch, the millis will run for over 49 days, almost 50 days. So once it reaches that point, that many number of milliseconds, right, for 50 days, then the millis will reset back to 0. So this will become true. This will be close to the 50-day mark. And this will return back to 0. So then now this will be smaller than this. And so that's why we have an OR function here for our if statement. Okay, so anyways, we're going to update the previous millis to the current time. This is the code for temperature, same as before. We're just going to confirm and print it on the serial monitor, but once you get this started up, you can get rid of this. And then this temperature is going to be a float. So what we're going to do is convert that to a character array. So it's in the proper format for us to send through the nRF24L01. Okay, so we create this array, and then we're going to use D to stir F again, another Arduino function, and we're going to take that temperature in Celsius, which is a float, and we're going to print it as a string, okay, for our character array. It's going to have a minimum of 1 digit. It's going to have more than 1 digit, but this argument here, this 1 here is for the minimum number. This is for the number of decimals. Okay, there's some more information on here, so if you're going to get a little more complex, you might want to have a look at some of this information. But anyways, we now have a character array for our temperature data. So again, if it was 21.51 degrees Celsius, then it's now saved as 21.51. Okay, just a series of characters. Okay, our character array. Okay, here is another character array. Now, actually, this is kind of redundant, and you don't need it in the way this is set up right now. We created a character array. We saved our float into that character array. And then there's another one here. The purpose of this one is really if you had multiple sensors and you wanted to save all of that data together in one string that you're going to save to your microSD card, this is the one that you would actually save to. So here, similar to previous, we have the sprintf, and we're going to print into this character array. Okay, so it needs to be big enough to take all the values. Right now there's just 1 in here, but if you had integers and bytes that you wanted to save in there, then previous to or similar to the server example we just did, where we had several integers, you could save several different types of variables, including this, which is now a string right now, into this data array. So you would just put all the different types separated by commas in here. So %I, comma, %s, like here, and then comma, and then you would have the name of the variable, the integer variable, comma, and then this one right now it says float value, but it's a character array, right, from up here, right? And so you would save all of those into this data array. But just to keep this demonstration simple, I only have just the temperature, so there's only 1 value here. But if you had multiple ones, you could save with this sprintf into your big character array here. So you would have to increase the size of this. Once you have all of your data now saved into this, here we're just printing it out to confirm out to the serial monitor, but you don't need to do that. You can get rid of this, okay? And now we are about to send it through our nRF24L01. That's what this statement means. And so here we're going to send, okay? We're going to send to our server, so we have to tell it what address. We're sending our data character array from up here, okay? And then we need to declare the size of it, but we're just using this function, which will look at our character array and indicate what the size is right there, okay? So that's what these 3 arguments are for. We have to declare, so a variable for the size of the buffer, okay, that we're going to send. Again, the address that we're going to receive from. Here, when we receive it, when we send it out, we're going to wait for our acknowledgement, okay? We're going to save our acknowledgement. It's going to be a certain size, so that's why we need to have this here. We're going to have a maximum of 2,000 milliseconds that we're going to wait, and then we need a place to put where the address is from the message that we receive, okay? And so then here we're just printing all that out to the serial monitor, who sent the reply and what was their reply. And if you remember back to the server sketch, it's just an OK. So that's what we sent. That's what would be sent to our serial monitor. If we don't get a reply, we're just going to indicate that. And then if we sent but it failed, then we're just going to write that here. Okay, and then that's the end of this portion in our loop, right? From back to our 10-minute interval, we went through all of this. Here is the end of it. And so then the Arduino is going to go through the loop over and over and over again until one of these, either this or this, becomes true. So essentially every 10 minutes. Okay, and so that's the coding that we have for our client. So I did that, and I had the server on the main floor, and I had the client measuring temperature in my basement. Both were plugged into the wall. And let me just show you what the data looks like. Okay, so this is our microSD card. So we've inserted it into the computer. This is the log3 file. So here I left both Arduino running for about a couple of days. So here's April 1st, okay, April Fool's Day, 9 a.m., 54 minutes, so 9:54, 28 seconds. And then you see 10 minutes later, approximately, 10 minutes and 1 second, it sent data again, okay? And then 10 minutes later, it sent it again. 10 minutes later, sent it again. 10 minutes later. And so here you can see it's sending data every 10 minutes. You'll see that over time it's not quite exactly 10 minutes. We are kind of, looks like we're just over 10 minutes. Okay, so this is the last signal before midnight, and then on April 2nd at 12:04, 59 seconds, again the next one. And so you can see it's sending data. It's now 8 a.m. in the morning here. Okay, it's lunchtime here in the afternoon. Okay, again, midnight again. Okay, and so the client Arduino was in my basement sending data, and the server was on the main floor. And so it's not really too exciting. The temperature didn't change too much. 18, 19, 21 degrees. Just trying to select it all here. So this is all just the temperature. Okay, and if I go to insert here and choose one of these graphs, I don't know, any of the graphs. Okay, so you can see with the data logger, now this is just the succession of measurements across the bottom here, but you can see there's going to be some noise, but overall there is a trend here of temperature changes over time in my basement. Okay, and so I've recorded all of these with the data logger. Okay, so hopefully you found that useful, and you can try all kinds of different sensors. Okay, this is just a simple float that we're sending to our data logger. It sends an acknowledgement back. If it doesn't send it back, it can send multiple times. I think the default is 3 times to help get reliable transmission of data. And that's our example of telemetry. Okay, in the next video, I'm going to show with a couple of clients, so 2 different clients sending data separately and logging both of those on our server. Okay, I hope you found that interesting. I'll see you in the next video.